Hello everyone and welcome to my presentation on AWS Infrastructure Design. This presentation is part of my professional portfolio and will be available in my Git repository as a video on YouTube showcasing my skills in designing a robust cloud architecture. I will walk you through the key components, the requirements, the risks and optimizations of a prototype design to demonstrate how to build an efficient and scalable cloud solution. To build a resilient and scalable cloud infrastructure, this architecture addresses key needs. We use a multi-availability zone deployment to ensure continuous service, even during failures. The EC2 instances are placed in private subnets, reducing exposure to external threats. With autoscaling groups, the infrastructure automatically adjusts to handle varying traffic demands. The relational database is fine-tuned for high availability and optimized performance, and resources are allocated smartly, balancing performance and cost management. Also, this design is robust. There are some risks and challenges to address. While the application load balancer is highly available, misconfigurations or traffic spikes could impact the performance. High traffic may lead to slow queries if not properly optimized. Autoscaling can increase expenses if thresholds and policies are not fine-tuned. Misconfigured security groups or IAM roles could expose potential lags. And some organizations, such as schools, may have existing applications that are not optimized for cloud environments, leading to slow startup times and inefficient scaling. To keep infrastructure reliable and efficient, I apply several strategies. I use health monitoring on load balancers to detect failing instances early and ensure high availability through redundancy. For databases, I implement read replicas, caching and indexing to boost performance and reduce load. And on the cost side, I combine reserved instances for predictable workloads and spot instances where flexibility allows saving. Security hardening is a must, refining IAM roles, locking down security groups and enabling services like AWS WAF to protect against attacks. In some environments, like schools, we face legacy applications that aren't cloud optimized. Here I containerize applications with Docker, then run them on ECS or EKS or even Fargate to avoid infrastructure overhead. Alright, let's talk about one of the most important but often overlooked parts of any infrastructure: backup and recovery strategy. Why is this so important? Because even the best system fails, disaster happens, and when they do, recovery is everything. In this demo, I'm using Amazon S3 as the primary destination for backups. I can easily copy database backups from a database instance directly into Amazon S3. This can be done using a custom backup script with the AWS CLI or one of the AWS SDKs. My strategy includes scheduled backups with versioning, lifecycle policies, and test recovery. We don't just take backups, we test loading a data dump from S3 to ensure everything works. Because a backup you can't recover from isn't a backup. Recovery effort is worth it. So if you take away one thing, have a plan, test it, and use reliability storage like Amazon S3. Now that you've seen the backup strategy, let's talk about how I've ensured it's secure. I've carefully assigned IAM roles to resources, ensuring that each component from EC2 to RDS has the minimal permissions necessary. This follows the least privilege principle. For data security, I've enabled SSE KMS for the RDS database and SSE S3 for any interactions with S3. This ensures that sensitive data is encrypted both at rest and during transit. Access logging and CloudTrail to track every action in the environment. This ensures I can audit and monitor all API calls, which is critical for security and compliance. I've applied several key strategies to keep AWS costs under control without sacrificing performance. First, I use instance right sizing and autoscaling to match resource capacity to actual demand, scaling up when needed and scaling down when it's not. For predictable workloads, I recommend reserved instances or saving plans. They offer significant long-term discounts. Where possible, I consider serverless services like Lambda, which only charge for actual usage, ideal for event-driven or lightweight applications. I tag every resource stack with identifiers to track costs clearly, making it easy to analyze which part of the infrastructure consumes what. And finally, I've automated template cleanup. Stale or unused environments are deleted automatically to avoid hidden costs. As a final step, let's talk about automation and testing, crucial for delivering reliable cloud infrastructure. Beyond just unit testing, I focus on automating everything from deployment to infrastructure validation. For infrastructure as code, I use tools like TerraTest to test Terraform configurations. This includes not just syntax checks, but also load and performance tests to simulate real-world usage. Automated deployment pipelines help me ship changes faster and safer, reducing human error and making the process repeatable. So in short, testing and automation aren't optional, they're essential for building stable, production-ready systems. This project reflects my ability to design, secure, optimize, and automate modern cloud infrastructure. If you're looking for someone who understands cloud security and best practices, let's connect. Thanks for watching, and I'm excited for what's next.